Hello Internet, today I'm going to talk about Atoms, a features and streams library that's going to be coming very soon to Unity3D. If you don't know what features or streams are, check out the Dart Async library. And in the demo, we're going to redo Astar's getting started with Atoms. Astar is a library that helps you find routes in complex environment using the Astar algorithm. Um, I'm gonna first talk about the basic structures in atoms that are the atom, the chain, and the sequence. Remember that all chains are atoms and all sequences are chains, where an atom behaves like an enumerable or coroutine, a chain behaves like a future, and the sequence behaves like a generic enumerable. Also, streams behave like events of actions, and generic streams behave like generic event of actions. The purpose of all this is to get composable async behavior, and you'll see how we achieve this with atoms. Okay, so first we're gonna see what you get if you follow Astar's getting started. You set up an environment, and if you do it alright, you're gonna get that your character it's going to be able to find the path to any point you want and then actually follow it and notify you once it reaches the path. If we look at the code, it's divided into three parts. First, in the start, you start to find the path to your target position. Then you get the path back on a callback where you just save the path. And on the fixed update is where everything occurs. And it does the walking and the stopping. But it suffers from the problems that you get every time you try to write an async procedure in a sync function, is that you get all these conditionals just to know if you have already started or finished or doing something, and you also get these fields like the path that are just there mostly, or like the current waypoint, they're there mostly to keep track of something, and we're gonna see how we're gonna fix that with atoms. So to do that, first we're gonna divide the problem into a set of smaller problems, and we're gonna be using atoms and streams to do that. So first we're gonna just walk to a point, and we're gonna use this keep doing atom, where we're gonna keep executing a single action that walks to a point, and we're gonna reuse the code up here which does the same thing, but this time, since we're solving the problem of walking to a single point, we're just gonna give that point here, and we're gonna make this code look a little bit nicer. And with this, we already get the walking behavior, and now we're gonna actually put the stopping mechanism because we don't want the walk to walk forever. So we're gonna use this while, which takes a condition, and it's going to keep doing the previous thing while that condition meets, and that condition we can get it from over here. That is that we want to do that while we are far enough from the point we want to go to. So we can already walk to a point with this walk to item. Now we're gonna solve the problem of getting the path, And for that we're gonna get a chain that is a future of the list of points of the path. And we're gonna first create our own stream of a path, and we're gonna call the seeker start path a start path method to find a route from our current position to any point we are given. And then instead of giving a callback, we're gonna give it the stream's broadcast, which is used to notify the subscribers to the stream. And we're not going to subscribe to the stream, but we're going to get this basically this chain or future using the first method of the stream that gives us back a future that contains the first value, in this case a path, outputted by the stream. But we actually don't want the path. We don't want to chain to the path. We want to chain to a list of points in the path. So we're gonna extract that by mapping. So we're gonna map from a path to the vector or the list of points of the path. And with this we get back what we wanted, which was a list of the future with a list of the points of the path. And finally we're gonna do a function that follows a path, and this is going to be really easy since we already have the walk to atom, and we are going to first convert the path to a sequence using the atomize. Remember that enumerables are very similar to sequences, and you can in fact convert them. And then we're going to use the bind each property of the sequence. If you're familiar with functional programming, this is actually very similar. In our case it won't be, but in some cases it will actually be a monadic bind, where we're gonna get a single point and we're going to do a behavior with that point. And here given a point, we want to walk to the point. So basically with this short code you actually get a procedure that goes through all the points. And lastly we want to recreate the notification in the log that we finished. So after we followed all the points, we want to print in the log, and we just do it like this with a do after the whole process. And since we already have our follow path atom, we're gonna first erase other things we don't need. This includes the current waypoint field and the path field that were previously there just to check the state inside the fixed update. And we're going to do everything in the start by first using the get path to atom, and we're going to give it the target transform position, and this is going to give us back a list of points which we're going to use using the bind property. This is also very similar to a monadic bind for futures, where we get a path and then we want to follow the path. And finally, we're just going to do this start method, which is a helper method to get back and initialize a core routine. And if everything went well, we should actually just see the same behavior as before, and it worked. But we see that when it reaches the end of path, it's just going to do it once, because this doesn't occur like in an event loop, but it's actually a core routine that knows where it is, and it knows how to do things only once without checking extra conditions. So the final code you get, you see that it's very short and it's very composable. You could reuse these functions like get path to and follow path for in many different situations, or even walk to a point. And now, just to show you how easily it's to compose new stuff, I'm gonna create a behavior of patrolling a path instead of just following it once. So patrolling is going through the path back and forth. And for that, we're gonna first import a link queue, because we're gonna do a trick with enumerables. And first we're gonna follow the path as we already done, but then we're gonna follow the path but using in the reverse order, using this link queue function. And once we went on one direction and on the opposite direction, we're actually going to cycle the whole process. So we go back and forth forever. And this simple could be a one line, but here I made it into three. This simple 3 lines, you could actually patrol the route instead of just following it. And if we press play, we're gonna see that our character is gonna go back and forth to the same route, notifying us when it reached its endpoint. And hopefully you like the composable behavior of atoms, how you could create new behaviors easily from old behaviors, how each function is very small and concise. And in the next video, we're actually going to extend this example using a special atom called a state machine, where we're gonna use the previous functions that we have already created to make an AI that patrols the path, but also follows a player if it's close enough. And if it loses sight of the player, it's going to actually go back to patrolling the path on its own. And the code, it's very nice, because we're going to totally reuse what we've already done and just add us like some transitions between the behaviors, and that's it.